Hello students, I hope you're doing well today. Today I want to talk to you about the course Elpt1311, and we're going to be doing Lab B-2. So if you look in your book at Lab B-2, I'll have some notes here that I'm going to hand out in class. And we're basically going to talk about how to fill out this VRP chart. And if I lay that out flat, you can see we're going to calculate and solve for voltage, current, resistance, and power. So those are going to be available to you. I think for the most part, we're going to understand this as a paper exercise. It asks you to draw these circuits, the circuit with 4 resistors in it. This is in parallel. And then here's how I do my charts here. As I remove the resistor sign, I simply put the number inside there, and the resistor equivalent, if we go through the reciprocal formula, comes out to be 271 is the equivalent circuit there. So that's what they're looking at on that page. But we're primarily going to have this lesson is going to be about page 42. So what you will need is there's a couple of things that probably will help you out. If you look at page 94 in your workbook, you've got the power of tens here, but you also have this power wheel here, which uses the unit of measure in order for to solve either for voltage or current or ohm or resistance or power, what we refer to as volts, amps, ohms, and watts. So I've given you a similar type chart in just a single page that you can have available to you. And if you don't have one of these, I'll make sure you get one of these. But this is what we call the power wheel. You'll see this also if you have an Uglies guide. You'll see this on the Uglies guide and that type of thing. So referring back to page 42, this is the table that we're going to be working on right here. So we're going to be working on this table, and we're going to be solving for volts, amps, ohms, and watts in these 4 resistors. Okay, so this is going to be page 1 of what you're looking at. And what you will see there is that there appears to not be a whole lot of information here. We have the value of resistance for R2, and then we have watts and amps for R3. We have watts for 4, and we have the total resistance here. So we're going to take what we have and work with what we've got. So we're going to make this a paper exercise, and here's the chart from page 42 that we're working with. And the idea is that we're going to take this information and work with what we have in order to solve for our problem there. So the first thing I recommend doing is we're going to start by finding what R3 is. Because on R3 is we have my power and my current there. And so we solve for R3, and we take, if I look at my power wheel, if I look at either this power wheel or what you have on page 94, we're going to solve for voltage when we have watts and amps available to us. So we're going to take that 206 watts and divide it by 15.853 milliamps, and that's the problem I have here, and we come to 12.99 volts. So what we will do is we will call this 13 volts. So when I solve that, and I realize that in circuit configuration, when I have a parallel circuit, or when all components are attached to the source, one side to the positive, one to the negative, is the voltage that goes through R1, goes through R2, goes through R3, goes through R4, and that is also my total voltage. We are going to take that 13 volts we solved for R3, and we're going to just put it on our chart everywhere. So we're starting to fill out our VRP chart here. So that gets us along the way, and what I've done here is I've transferred that chart to the top part of this page number 3 in your handout. And we're going to use the power wheel and the lines on the chart to determine our next step. So we solved for R3. We solved the voltage. We put that voltage here. And now what I have available to me is if I go look up one line is that I've got the volts and I've got the ohmic value here. I just transferred that 13 we calculated here to all these spaces here, and now I can solve for resistor 2. So what we have here, so I'm just using this formula I found on the power wheel, is amps is equal to volts divided by ohms, and 13 divided by 2700 is equal to 4.8 milliamps, and we transferred that on our next chart. We'll transfer that. Now that I know what my current is, I can solve for power, or for watts, for my R2. And I take that 13 volts and I divide by 4.81 milliamp, and I multiply that, 13 times 4.81, and I get my power of 62.59. Now we can go and start looking at what we need to finish up on R3. Is on R3 we solve for voltage. Now we're going to solve for current. What we did there is we found that the voltage was 13 volts. We can see here, and that my current was 15.85. And if I take the voltage divided by the current, I'm going to find my 820 ohms. That's going to go in this slot right here, right there in that square. And moving along, we're looking at solving for R4. And the way we solve for R4, what do we have available from R4? We have our voltage, we have our power, and so we look at the power wheel accordingly, and we find out what equation we can use. And if I have my watts and my volts, I can solve for amps. And I take that 169 milliwatt divided by 13 volts, comes out to be 13 milliamps. And then if I want to solve for ohms, I take the 13 volts divided by 13 milliamps. 13 divided by 13 is 1, and the inverse of a milli is a K, so that's going to be 1 K ohm. So that's page 3 of the problem. And if I look here, and I need to solve for the total values here. Okay, so I need to find out what the total current's going to be and what the total voltage will be. And again, we're working our way back to finishing all that information we need to fill out for page 42. So I take my total voltage and I take my total resistance, and I divide my ohms into my volts to get my amps. And that's what I've done here. So 47.95 is my total amps. And then I take my total voltage times my total amps, and I go through that equation, and my total power is 623.4 milliwatts. And now the one thing I haven't solved for, and this is the last thing, is we're solving for the values for R1. So the way we do that is we take what we do know. We know what the total current is. We know the branch currents for R2, 3, and 4. If I subtract these 3 values from my total, that's whatever's left over is what is the value of R1. So 14.29 is milliamps is for the current for R1, and I take that current and divide it into my voltage, and I get something close to 910 ohms. So that's what that looks like. And then we just go through and finish line 1 by taking my the power is going to be equal to the voltage times the current of the values on R1, and that's what I've solved here. This 185.77 milliwatts. So if you look at my chart here, this correlates to how we solved the chart. I know I went through that pretty quick, but you can slow this down and work on it yourself. You see the dark numbers here. These numbers are the one that were given to you in the handout. And then we went step by step to fill in all these things. So we originally solved for voltage first, and then we took what we knew about 2 and solved for 2, and then we solved for 3, and then we solved for 4. Then we solved our totals, and then the differences we figured out to find out what the current for 1 was, and then we were able to calculate both the resistance and the power for R1. So I'm hoping that this will be helpful to you in finding the unknown values on a Verpi chart with the known values that are given to you. Thank you, and we'll see you in class.